Hello and welcome to this video on section 7.5. This is on conditional proof. So in this video we are not introducing any more rules. We have all the rules that we already need. We are doing something quite unique and different. We are still proving certain conclusions, and what I have here is three arguments with some premises that are given, and we're going to prove the conclusions that are over here on the right. Remember, I always write the conclusions here on the right hand side, on the top right. And what we're going to do is we're going to use a method called conditional proof, where we assume certain things to be true, and then based on those assumptions we draw certain conclusions. So this is a very unique and different way of proving certain conclusions. Notice that all the conclusions we're proving are conditional statements, and that's actually very important for how the whole structure works. So I'm just going to do these three here, and then I'll do the first one on MindTap, just to give you an idea of how this is supposed to work. Okay, so the idea of a conditional proof relies on the making of an assumption. And if you think back to the structure of an argument has premises which are intended to prove a certain conclusion. Well, if you think about it, premises are, in a certain sense, assumptions, right? Because we take them to be true. We assume that they're true. We assume that the premises are true. The only difference is basically that the premises are explicitly written assumptions. So when you have them as an actual premise in an argument, they're explicitly stated or written. Not all assumptions are explicitly stated or written. And so what we're going to do here is we're going to make some of those kind of unwritten assumptions explicit and written, and then when we do that we can use them as premises in the whole argument to get the conclusion that we're trying to prove. So let's start with this first one here, that we're given if m then n, and we're trying to prove if not n then not m. Okay, so so what we have to do here is, for all of these, we pretty much have to assume the antecedent. So notice, and we do have to look at what we're trying to prove. We have to assume the antecedent. In this case, the antecedent is not n. So we have to assume that, and we do have to shift over to the right when we do this. This will now be our second premise in which we're assuming the antecedent. The way that this is done is this part of the proof is shifted over to the right, and then when we're done with that part of the proof, we'll come back to the left and get the conclusion that we need. So when you submit this for your final exam, make sure that you could hit the tab button. What I just did right now is hit the tab button once to indicate that you are doing the conditional proof and that you're assuming this and you're stating this to the right. Okay, so we are assuming the antecedent, which is not n. We do have to cite this, and the way that this is cited is ACP, and that stands for Assumption for Conditional Proof. ACP, and that's all. That's all that you have to do in terms of citing that first assumption there for the proof. ACP, Assumption for Conditional Proof. Again, we're assuming the antecedent, and we're trying to get the consequent. You'll see that eventually what we're trying to do here is get the consequent, which is not m. Okay, so our next step is to use the regular rules and get that not m, which is what we want, right? The antecedent here, the not m. Okay, if you notice, there is a rule here that we can use to get that not m. And that rule is modus tollens, right? Because we have if m then n, not n, therefore not m. Remember, modus tollens works if p then q, not q, therefore not. Here, the p is the m, the q is the n. And if you go back and look at that form, that's what I'm doing. I'm following modus tollens. So modus tollens is going to give me not M, and I'm using it on lines 1 and 2, right? That's what I just did. Lines 1 and 2, um, modus tollens, right? Okay, well notice that I now have the not and I have the not M. So now I can get the conclusion that we were trying to prove. And here's how the next step is justified. We go back to the far left where we started, and we write out that conclusion that we want. And now that is justified by citing lines 2 and 3, which is where we did the whole conditional proof part, um, and that is cited as lines 2 and 3. CP for conditional proof, and that's it. So notice the word conditional, by the way. It's called conditional proof because we got everything on the condition that not n was true or was assumed to be true, right? So there's that might help to remember why this is called a conditional proof. On the assumption that not n is true, we got what we wanted. We got the conclusion that we wanted, and so that's why that is cited at the end there. It's cited as 2-3 conditional proof. Okay, let's go on to the next one. I'm going to do two more, and then we'll do one in MindTap. We'll do number one in MindTap to show you how this works in MindTap. Okay, so here notice that we're trying to prove if x then w. Again, we want to assume the antecedent, which is the x, and eventually we want to get the consequent, which is our w. And again, we're using the same rules. We're following the same rules. We're not adding any rules. We're using all the same rules that we have. It's just that we're using them in a unique way to get these conditional statements proven. Okay, so our first step here, again, I hit the tab button. Our first step here is to assume x. And again, remember that's an assumption for conditional proof, ACP. We're assuming x to be true, and then we're using the rules to derive further premises. I do want to do everything over to the far right, so I'm hitting the tab button and going to line 4. Okay, so now that we've assumed that x is true, what can we further deduce? Okay, well notice that with lines 1 and 3 we can use modus tollens. Let me get rid of this squiggly line here because it does look confusing. So for this I have to do a spell check here. So I'll just click ignore. Okay, there we go. All right, so again, what I'm doing here is I'm assuming that x is true. That's the assumption for the conditional proof. I am now deriving my next premise, deducing my next premise. And notice that with lines 1 and 3 we could use modus ponens. Remember, modus ponens is if p then q, p therefore q. Well, our if p then q is our line 1 there, right? Our x is our p, and our q is our whole statement here, the t or w, that disjunction there. So, and then our p again is here, right? If p then q, p therefore q. So our p there is again the x. So we could get t or w, and we can do so by applying the rule of modus ponens to lines 1 and 3, right? That's what I just did. And again, I'm citing these as I normally would. I'm doing what I did before, just citing them as we did before. Lines 1 and 3 modus ponens. Okay, now we should get that w, right? Because that's what we wanted. Remember, we want to get the consequent, which is that w there. Okay, well notice that for line 5, it's easy to get that w because we have t or w and we have not t. That should remind us of our disjunctive syllogism, our DS, right? Remember, disjunctive syllogism is p or q, not p, therefore q. Well, our p here is our t, our q is our w. Excuse me, I have a little bit of cold. Our p is our t, our w is our q. So we have our form here, p or q, not p, therefore w. We have not t, therefore w. So in line 5 we deduce w. We did so by applying lines 2 and 4, um, disjunctive syllogism. Okay, now we have what we want. We have our X and our W. So now we do this next move. By the way, this next move does have a name. It's called discharging the proof. So that's the last step here is the discharging of the proof. Um, so here we have if X then W. Let me copy the horseshoe here. If X then W. And we did so by, remember, using lines 3 through 5. Those are the ones on the side. And then we cite that as CP, conditional proof, and that's what we wanted to prove. Okay, I'm going to do one more, which is a little bit longer. But again, the more practice that you see, the better. Okay, so in this one, we want to prove all of this over here on the far right. F and G, if F and G, then M and U. So again, I want to start by stating the assumption for the conditional proof. I'm going to move the tab button, hit the tab button, move here to step 3, and you know, typically we just assume the antecedent, which in this case is F and G. So I'm just going to copy and paste that here. And that's the ACP, the assumption for the conditional proof. Okay, so now notice that I have F and G that is being assumed. Notice the first thing I can do there is get that F out of there by simplification, right? I can simplify 3 and get that F out of there. How is that going to help me? Well, look, it's going to help me because we could use modus ponens with lines 1 and 3, right? Modus ponens, if P then Q, P therefore Q. Our P here is our F, our Q is our M. And so we could get M in line 5. Again, it's shifted over to the right. We get M by modus ponens. Oh, I need to cite the number for simplification here, which is I simplified line 3. In line 4, what I did is simplify line 3. So I do need those numbers. Let me make sure I have the numbers for the others as well. Yeah, it looks like I have the numbers for the others as well. Okay. Got to be very meticulous about having all those numbers there. Okay, so line 5 here then is justified because we did modus ponens on lines 1 and 4, right? So 1 and 4, MP. Okay, so do I have what I need already? No, not yet, right? I need M and U. I do have M, so now I need to figure out how to get the U. Well, notice that the U is over here in line 2, right? It's the consequent of that conditional statement there. The question is, how do I get it? Well, notice that if I had the G, I could use modus ponens to get it, right? So let's get the G. So, okay, in line 6, I can get the G. Notice that the G is up here, right? F and G. It was assumed as part of that conjunction. Except it's not in the position where I want it so that I can use simplification. But remember that there's a rule that allows me to switch the order of the F and the G. That's commutativity. So if I apply commutativity to line 3, I can cite it as COM, then I get that G in the first position. And so in line 7, I can get the G out, right? And that's because I can simplify line 6 now. So all I did there again is apply the rules. I switched the order of the F and the G's to put the G in the first position. And you do have to go through this because this is how the textbook teaches it. You can't just get that G out of there because it's not in the position that it's supposed to be. But we could do commutativity, switch the order, and put that G in first position so that then we could simplify 6 and get the G out of there. Okay, so now I do have the G, which remember I wanted to get so that I could get the U out of there. So now look, you could use modus ponens, if P then Q. So our P is our G, our U is our Q. P, which is G, therefore Q, which is U. So line 8, I can get U. And what I did there is I applied modus ponens lines 2 and 7, right? MP for lines 2 and 7. Let me move these over a little so it doesn't look confusing. Move the justifications over so it doesn't look kind of all mumbled together, jumbled together. Okay, so I have M and I have U somewhere here, right? In fact, I have it in line 5 and line 8. And remember, I do want the M and the U together. Okay, well, that's easy. All we have to do is conjoin them, right? So M and U is our line 9 here. Line number 9 is M and U. And that is justified by numbers 5 and number 8 conjunction, right? Which remember is C, O, and J. Okay, look, I have everything I need. I have the F and the G, which is the antecedent. I have the consequent, right? The F and the G is the antecedent. And then the M and the U is the consequent. That's what I wanted to prove here, right? The F and the G is the antecedent here. In this part, let me highlight that. And the M and the U is the consequent. So I can now discharge the proof. So line 10 is going to be what I want to prove, which is, let me copy that. Line 10 is what I wanted to prove, which is if F and G, then M, let me do that again. I don't want it highlighted in the, I don't want it highlighted in the conclusion here. If F and G if F and G, then M and U, right? And so this is called the discharging portion of the proof. I do want parentheses around the M and the U to separate it from, clearly separate it from the antecedent. And so remember that this is cited as lines 3 through 9 CP for conditional proof, and that's because I used lines 3 through 9 for that conditional proof, right? And that's it. That's what I wanted to prove. Okay, so that looks easy enough if you just follow the rules and do this unique way of assuming something and then usually the antecedent and then getting the consequent. It's just a unique way to do a proof. All right, let's do number 1 in MindTap so that you can see how this works in MindTap. Again, you know, we're doing the same thing here, it's just a different format. So here we have the premise, which is, we have two premises. We have the premise, which is if N, then O. And then we have another premise, if N, then P. And the conclusion we're trying to prove is over here, right? If N, then O and P. Okay, well, this is going to work the same way. We're going to assume N because that's the antecedent, right? And we're going to try to get O and P. So we write N here. Notice that ACP is over here. Again, remember that's the assumption for the conditional proof. And we don't have to do anything further there. We just cite it as ACP. So now we want to get O and P, right? That's the consequent. We want to get this O and this P together so that we could discharge the proof. Okay, well, notice that the first thing I can do here is use modus ponens with lines 2 and 3, right? If P, then Q. P there for Q. The P there is the N. So I can get P by applying modus ponens to lines 2 and 3, right? And that would be legitimate. That would be fine. Oh, and notice how in MindTap it automatically shifted it over to the right. So on my proof here, I had to click the tab button, but in MindTap it automatically shifts it over to the right. Okay, so I have P, now I need O, right? So that I can conjoin those eventually and get O and P. Okay, well, notice that the O is in that consequence position in line 1. So that's easy because I have N over here by itself. So again, I can use modus ponens. Again, notice how much modus ponens comes up. If P, then Q. P there for Q. Our P is our N. Our Q is our O. Our N is there again. So we get O in line 5, and our justification there is lines 1 and lines 3, modus ponens, right? MP. Okay, so now I have what I need. Well, not quite yet. I do need to conjoin O and P, right? Because that's what we have as our consequent here. So let's do that. O and P, and that's very easy because all we're doing is conjoining lines 3 and 5, conjunction. Okay, now I have what I need. I have the if and the O and the P, right? If and then O and P, which is what I wanted. So now I can discharge the proof. Let's see what went wrong here. 3 and 5 conjunction. O and P. Oh, I think I have to click on conditional proof. Let me go back. Back one step here. Oh, did I not cite O and P correctly? Okay. O and P. Or did I not get the O out of there correctly? Let me backtrack a little bit. So, O, remember we got it with lines 1 and 3 modus ponens, right? And so that should be fine. Now we want to get O and P conjoined, so that's O and P, and that is lines 5 and 3, and the order here doesn't matter, by the way. Conjunction, if I do 3 or 5 or 5 or 3, that doesn't matter. That's what I mean by that. Okay, it's telling me that this is wrong. Why is it doing that? Oh, I'm citing the wrong lines. That's why. I just noticed my mistake. I'm citing 3 and 5. It should be, let me do that again. It should be, I'm conjoining, I cited the wrong lines. Let me go back. So O, we got with 1 and 3 modus ponens. And then the conjunction is between, it's between 4 and 5. That was my mistake. So O and P, and that's lines 4 and 5. I was citing the wrong lines. 4 and 5 conjunction. That gives us that conjunction that we want. Okay. Our next step here is to discharge the proof. And so remember, we want to show that if and then O and P follows by lines 3 through 5, and that's through conditional proof. So I should be able to hit CP here, and notice that it does shift over to the left like it's supposed to. But I do want to cite lines 3 through 6 for conditional proof, because that's where the conditional proof was all done. Remember that was under the assumption that n was true, assuming n is true. And so that is it. That is the discharge of the proof. That proves the conclusion that we wanted to have, which was if and then O and P. So this should say that, give us the feedback that it is correct, and in fact it does. Okay, so that is it for for this video on conditional proof. Again, keep working on the videos. Keep working on the exercises so that you are prepared for the final exam, and so that you are prepared for your homework. Okay, take care.